We are in last lecture of this chapter, carbon and its compounds. So in this lecture, we are going to see what are the additional functional groups can be added to the carbon compound, existing carbon compound, such that how those properties will change and what are the new names. Simply to say, it is nomenclature. So what is that nomenclature? It is simply to say we need to name a compound, hydrocarbon compound, and if functional groups are added to hydrocarbon compound, how it can be named. That is the thing. Okay, let us try to understand. So first of all, we have hydrocarbon compound, and these functional groups in 10th class we are applying only for alkanes. In 11th and 12th, you will be seeing how it can be applied to alkanes and alkynes or something. But here only have to remember that these functional groups, let me take we are in lecture 5. So these functional groups that can be added to hydrocarbon compounds. So what to add and how to add, that we are going to see. So first of all, I told that it is added for alkanes. Just a minute. So here you can observe this is a textbook page. Here they have given few functional groups here, functional groups, and formulas of functional groups also you can observe here. Okay, what are these functional groups and what are these formulas, how to apply and how to name, that we are going to see now. Okay, so what I told, functional groups to be added for hydrocarbon compounds, and in that hydrocarbon compounds we are going with only alkanes. Alkanes general formula is CnH2n plus 2. Now let us go with a few alkanes. If you substitute one, it becomes C1H 2 1s 2 plus 2 4 CH4, which is nothing but methane. Then C2H 4 plus 6 ethane. C3H8 propane. So like that we have alkanes. Next here what we have to understand is there are few functional groups that will be added to hydrocarbon chain. For example, let us take propane. Propane, if you take, it is C3H8, 1, 2, 3, 3 carbons with 8 hydrogens. This is the structure of CH8. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 hydrogens and 3 carbons, which makes propane. Now you see guys, if you remove this hydrogen, this last hydrogen, and if you add some element in the sense, if you add functional group, what happens in the sense, entire physical and chemical property of that propane will change, because we are adding some functional group. It changes physical properties, it will change, chemical properties will be changed. So when physical properties, chemical properties are changed, simply to say this is a new compound, definitely it is new compound. If it is new compound, we have to name that new compound. Na? We have to name, how to name and what to name, that let us try to understand. So now let us try to see some example. Here in textbook they have given, like first you see halo, that is the first functional group. Let us try to understand. Halo in the sense where we can find chlorine or bromine or iodine, I for iodine. And also you see guys, whenever you are adding chlorine or bromine or iodine, we need to spell it as chloro, bromo, iodo, like that. Just try to understand those names. Just try to understand those names. I'll tell you how to do and what to do. And this chloro, bromo, iodo, they are prefix. Try to understand prefix. And all these alcohol, aldehyde, ketone, carboxylic acids are suffix. What is prefix? We need to give name front. Suffix means we need to give these names backside, simply to say at the end. So this is at the beginning. For halo, it should be in the beginning. And while coming to alcohol, aldehyde, ketone, carboxylic acid, those names should be at the end of the name. Okay, what is that beginning? What is that ending? We'll try to understand. First of all, you see, functional groups are chloro, bromo, iodo. So how to add? If I take this one, which one? Propane. I told you have to remove one hydrogen and you have to add one functional group. For example, if I add here, if I add new functional group, that is chlorine, because chlorine is also monovalent element, you can add it. Chlorine, if you add, you see entire physical property, chemical property of the compound has changed because of addition of functional group. Now, how to name in the sense, we are adding what? Chlorine. If you're adding chlorine, you have to name it as chloro. First of all, you have to spell it as chloro. Chloro what? This is how many carbons? 1, 2, 3. Meth, eth, prop. Chloro, propane. It is simple. Just as simple as thing. And also you see how to name this one. Hydrogen, 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 and we are adding bromine. Now, how to name this one means it is quite simple. First of all, we have to observe, is there any functional group or not? If you observe, yes, there is bromine. If it is bromine, we have to name it as bromo. Okay, bromo what? How many carbons? 2 carbons. First carbon, second carbon. Meth, eth. So it is bromo ethane. Simple. Bromo ethane. Okay, now let us see another thing. If a compound is like this, so we have hydrogens here. Just to make it simple, I am adding functional group at this place. It is not compulsory that you need to add only at this place. You can add anywhere in the compound you can add it. Okay, now I am adding another functional group, that is I. Now how to name this one means it is quite simple. Just by observing the chemical formula compound, you have to see what functional groups are present. If you observe iodine is present, so simply we can tell it as it is iodo what? 1, 2, 3, 4. 4 carbons. Meth, eth, prop, bute. It is iodobutane. That's it. Like that, we need to add halo functional groups. Whenever you find halo, I mean chlorine, bromine, iodine, this chloro, bromo, iodo, these are the names should come in front of the compound, like chloromethane. So if you observe this, chloromethane, if you observe, if you add only chlorine, chloromethane, chloroethane, chloropropane, chlorobutane, chloropentane, chlorohexane, like that. If you add bromine, bromomethane, bromoethane, bromopropane, bromopentane, bromobutane, something like that. If you add iodine, iodomethane, iodoethane, iodopropane, iodobutane, iodopentane, iodohexane. Like that, you need to add functional groups and we have to name those compounds. So that is about chloro. That is halo. What is this halo? In the sense, in 5th chapter we'll discuss in periodic classification of elements. They are halogens. Halogens are simply to say 17th group elements. 17th group elements are very reactive nonmetals. Those are halogens. We'll discuss there. Then we have another 4 functional groups. Let us see alcohol. And while coming to alcohol, I said it is suffix. Means we have to fix those names at the end. But entire name we cannot fix it. We have to fix root words. Root words. For all these 4 functional groups, we have root words. I'll tell those root words. and those root words should be fixed at the back, and there are structures also. First, let us see about alcohol. If we take alcohol, alcohol functional group, they have given bond OH. So remember that it is bond OH, means after one single bond, means carbon should be there. After carbon there will be one single bond. Not only here guys, it can be like this also, bond OH, that is also correct. For carbon this side also we can draw bond OH, or upside also for carbon up bond OH. Whatever it may be the place, there should be one single bond and OH functional group should be added. If we add, let us try to see few examples. Okay, alcohol is bond OH na, and there is one root word for this. What is the root word for alcohol? Means it is OL, ol. Okay, now let us take this structure. This is a structure and we have hydrogens here. Now instead of here this hydrogen, we have added this one, bond OH. Bond, already bond is there, no need to draw extra bond OH. Now how to spell? You see, from here, from alcohol, let us go with one pattern. While if you want to write the name, there are three parts. First part, we have to count number of carbons. Second part, we have to go with what is that? It is which homologous series? Alkane, alkene, or alkyne. Definitely, we are going with alkanes only. ANE, alkane. That is the root word for the alkane. And third one, name of the functional group. So try to understand. First part, count number of carbons. If you count number of carbons, it will be like 1, 2, 3. Not like 1, 2, 3. We have to count like meth, eth, prop. So first part we got, it is prop. And you see in between carbons there are only single bonds. Now definitely we are not going with alkene and alkyne, never in this 10th class. So that we are going with only alkane. If it is alkane, what is the root word? It is AN. ANE. Okay, no need of E, leave this E. Go with AN. It is AN. That is the second part. And third part, what is the functional group? Bond OH. Bond OH is functional group for what? Alcohol. And what is the root word for the alcohol? OL, ol. Try to write that functional group root word. It becomes OL, and we have to spell it like propanol. Simple, it is propanol. Let me go with another example. You can understand it easily. So whenever a compound is given, you see there is a compound, don't get confused. I told you, wherever you want, you can mention that functional group, but functional group should be mentioned. We have bond OH. So first of all, after giving compound, what we have to do? First try to see how many carbons are there and is there any functional groups are there or not. Yes, by observing the compound we can tell there is some functional group. What is that functional group? OH functional group. OH functional group is represents alcohol. Now I told there are three parts of naming. First we need to count number of carbons, not like 1, 2, 3, 4. It is like meth, eth, prop, but. Now if you count number of carbons, it is like meth, eth. There are 2 carbons, isn't it? So 2 carbons means meth, eth. It is eth. And in between carbon there is only single bond, right? So that it is alkane. Alkane means AN. And what is the functional group present? Bond OH. Bond OH means alcohol. What is the root word for the alcohol? OL, all. So it becomes ethanol. Simple. So like that we can get methanol, ethanol, propanol, butanol, pentanol, hexanol. Like that it will be going on. Like that we have to add alcohol functional group, and alcohol functional group root word is OL, that is suffix, means at the end of the compound we have to write. And at the same time, what is the structure of the functional group means bond OH, that you have to understand. Next functional group, let us see. So we are done with alcohol. And next functional group, here if you observe, it is aldehyde. Aldehyde. And the structure is, there will be one carbon, and carbon has 4 valencies, right? Carbon has 4 valencies, 1, 2, 3, 4. No problem in writing this, right? And for this one single bond will represent hydrogen, and for double bond will represent oxygen. And root for the aldehyde is Al, all. For alcohol it is Ol, ol. For aldehyde it is Al, all. Now let us try to see this. Now it is aldehyde. For aldehyde, root word is Al, all. And the structure is, there will be carbon. Carbon has 4 valencies, 1, 2, 3, 4. It is not, no need to mention here only. You can mention those 2 bonds here also. There is no wrong. Like this also, no problem. OH, sorry, not OH, it is O. So here it is given single bond H, double bond O, right? So single bond H, double bond O. Now how to apply this one, we'll try to see. Right. So let us go with a few structures here. Now, if you do like this, hydrogen, we can represent hydrogens here. Right. It becomes what? Meth, eth, it is ethane. It is just hydrocarbon compound. We did not remove any hydrogen. We did not add any functional group. Let us try to remove hydrogen and add functional group. Now, if you observe functional group here, it is single bond H, double bond O. Na? So if you wanna mention double bond O, you have to remove this hydrogen. You have to remove this hydrogen also, and this bond should be removed. After removing bond, you have to mention bond here. Then it is O. Here you see this side. Single bond H, double bond O. Now how to mention 3 parts, right? First we have to count carbons, not like 1, 2. It is meth, eth. Eth. Anyhow, in between carbon it is single bond only. Single bond means An because alkane. And what is the functional group we have? Single bond H, double bond O. Single bond H, double bond O means it is aldehyde. What is the root word for the aldehyde? Al. So it becomes ethanol. If you are adding alcohol, it is becoming ethanol. Huge difference is there. Ethanol is alcohol functional group. Ethanol is aldehyde functional group. We will see another example also. You'll get some idea. Now, let us take. Now here we have mentioned all hydrogens. Now to mention aldehyde, we need single bond H, double bond O. Now if you observe, how to name this one? First part, carbon count. Meth, eth, prop, but. It is but. In between carbons, we have only single bonds. So that alkane, An, and we have functional group that is single bond H, double bond O, that is aldehyde, root word is Al. It becomes butanol. If it is alcohol, it becomes butanol. So like that we have methanol, methanol, ethanol, ethanol, pentanol, pentanol, butanol, butanol. Like that, aldehyde functional group should be mentioned. Now let us go with another functional group, that is ketone. So what is that ketone? Here we have another functional group, ketone, and if you observe the structure, it is for carbon, this side, carbons only should present, not hydrogens. Why? If hydrogen is present, you see guys, hydrogen, single bond hydrogen, double bond O, it becomes aldehyde. Na? We have single bond H, double bond O. Again here if you have single bond H, double bond O, it becomes aldehyde. So that there should be carbon, not hydrogens, these sides for carbon. So ketone functional group is not applicable for meth and eth. For one carbon, 2 carbons, it is not applicable, because to apply this ketone, minimum 3 carbons required. Why? Because here there is 1 carbon, there should be 2nd carbon, there is 3rd carbon. So that three things required, three carbons required. Here, let us try to understand ketone. So another functional group is ketone, and root word is ONE, own, not one, not 1, 2, 3, 4. It is own. Pronunciation should be own. And what is the structure? Carbon should be there. This side and this side also there should be carbon. Here there should be double bond oxygen. Let us try to apply this. So I said it is not applicable for 1, 2 carbons. It is applicable for 3 carbons. Let us go with 3 carbons like this. And here there should be double bond O. And not only here. Oh yeah, it should be middle. It should be middle. So here we have to go with the valency satisfaction. While coming to this carbon, already 1 is there, 2, 3, 4. For second carbon, 1, 2, 3, 4 is present. So no need to mention extra. For third carbon, 1, 2, 3, 4. And mention hydrogens. Now it becomes what? It is quite simple. You can also answer this. Meth, eth, prop. Prop. In between carbons, there is only single bond. So that alkane AN. And there is functional group double bond O. That's it. Double bond O means it is ketone. Ketone means own. It becomes propanone. Quite simple. Propanone. And let us go with another example. 1, 2, 3, 4. 4 carbons, let us take. And you see, you have to mention double bond O. Wherever you want, you can mention. Either here you can mention or here you can mention, no worries. So valency satisfaction, first carbon 1, 2, 3, 4, second carbon already 1, 2, 3, 4 is there, third carbon 1, 2, 3, 4, fourth carbon 1, 2, 3, 4. Now mention hydrogens. So now what is the name of this compound? Means we have to count carbon, meth, eth, prop, bute. It is bute. All single bonds only there in between carbon, an. And if you observe functional group double bond O we have. So it is ketone means own. It becomes butanone. So simple. So try to understand. Meth, eth is not possible from prop. It is propanone, butanone, pentanone, isn't it? And we have applied this one also, alcohol aldehyde functional groups. So if you go with alcohol, it is propanol, alcohol, aldehyde, propanol. We have see propanol, propanol, propanone, butanone. And if it is alcohol, butanol. If it is aldehyde, butanol. Like that, we can go with n number of compounds. And let us see last one, that is carboxylic acid. Right, if you observe last functional group, that is carboxylic acid. If you observe that carboxylic acid functional group, there is carbon with a single bond OH, double bond O. If it is single bond H, double bond O, it would become aldehyde. If you can observe here, single bond H, double bond O, aldehyde. But here, single bond OH, hydroxide. So let us see this. We have carboxylic acid. While coming to carboxylic acid, I said functional group carbon, single bond OH, double bond O. Now, if let us try to apply this carboxylic acid for different hydrocarbon chains. If you observe, three hydrogens, and here single bond OH, double bond O. Now, how to write this one? It is quite simple. Count carbons, meth, eth. It is eth. And while coming to carboxylic acid, functional, root word, that is oic acid. Oic acid or oic acid, we'll see what is that oic acid. Eth. And in between carbons, there is single bond. It is alkane, AN, and it is oic acid. Oic. acid. Now it becomes ethanoic acid. Simple. Ethanoic acid. We'll go with another example. You'll get some clarification. Now I'll come to last carbon. Single bond OH, double bond O. Now we see how to write this one. Meth, eth, prop. So it is prop. In between carbons we have only single bonds, and there is functional group single bond OH and double bond O, that is oic acid. It becomes propanoic acid. So like that we can write it as for one also we can write. You see, there is carbon, double bond O, single bond OH, and here you can write single bond H, right? So carbon is satisfying 4 valencies, and this one we can write it as, how many carbons? We have only one, that is meth. It is alkane, and there is a carboxylic functional group, it is oic acid. It becomes methanoic acid, ethanoic acid, propanoic acid, butanoic acid, pentanoic acid, hexanoic acid, something like that. So those are 5 functional groups. First one, chloro, bromo, those are halogens. And this alcohol, root word is OL. Aldehyde, root word is AL. Ketone, root word is ON. Carboxylic acid, root word is oic acid. Then there are functional groups, structures. For alcohol, it is bond OH. For aldehyde, it is single bond H, double bond O. For ketone, double bond O, that is not applicable for meth and eth because minimum 3 carbons required. Last one, carboxylic acid, where carbon, double bond O and single bond OH. So that's it about this chapter. Basically, this concept is not there, but it is better to learn. And next we'll go with the next chapter, that is chapter 5, periodic classification of elements, in next lecture. That's it in this lecture, and we are done with chapter.